Okay, dear students, okay, Nana, this is part 3B. Part 3 is over. Part 3B. Okay, na? It is 3B. 1A, 1B, 2A, 2B, 3A, 3B. Like that. Two parts are giving. Okay, na? Now we will continue those problems. 44 problem is over. Now 45. The number of ways in which a team of 11 players can be selected from 22 players, always including 2 of them and excluding 4 of them is a fantastic concept. You see, in our group, in our hostel, boys, there are observed this 45th problem. 22 players are there. Okay, na? Players are there. Cricket players. Out of you, 22. You also one of them. But we have to select only 11. Selection of selection of 11 only. 11 members are needed. So very simple. It is 22C11. Out of 22 members, you select 11 members. Very simple. But the condition is there. 2 compulsory. You see, 2 members are compulsory. These are compulsory. Okay, na? They are compulsory. Compulsory means particular students. There is no need to selection for them. They have to be in the team, in the 11. Okay, na? KONNURS sir came and told to Nepal sir told to me that 2 boys must be there in the team, just like. So there is no selection for you to select. So I am taking that 2 boys from the total, 22 minus 2. Again, 4 members are excluded, including 22 compulsory students, 22, not 22, 2 members, and excluding 4 members. Those 4 members, their parents came and they want to go out or go to home. So 4 members are excluding, it is excluding. It is including, means compulsory, including. Okay, na? Total now is 22 minus 2 minus 4, 22 minus 6. How much is 16 students are there now? Out of 16, you have to select 11, not 11. 11 minus 2. Now the selection is 11 minus 2, 9 students, because that 2 particular must be included. There is no selection. And 4 members, they went to the home. Now the number of ways, selections, number of ways is equal to, that is, again I am writing 22 minus 2 minus 4, C 11 minus 2. That is 16C 9. This is the answer. In the option that is given. Sometimes this can also be written as, you see, 16C 7 also. That option may be there. Okay, na? If 16C7 is there, that is, or this one. But it is given in the option, you see there. Instead of 9, we may give this one, because a formula is there in the combinations. NCR is nothing but NC, N minus R. 16C9 is nothing but 16C, 16 minus 9, 16C7. Okay, na? Both are there. Is it clear? Yeah. Now, another one. You see, 46. A box containing 2 white balls, 3 black balls, 4 red balls. 2 white, 3 black, 4 red balls. In how many ways can 3 balls be drawn from the box? At least one ball is selected. At least one ball is to be included. Okay, na? At least one black ball is included in the draw. You see, Nena? Slowly we will solve the problem. Here, 46th one. The box is, this is a box. The box is containing 2 white, 3 black, and 4 red balls. Altogether, how many balls are there? That is 9 balls are there. Total number of balls are 9. How many balls are drawn? Drawn balls. How many? 3 balls are drawn. From the box containing 2 white, 3 black, 4 red, total 9 balls. We are drawing any 3 balls. Okay, now any 3 balls means very simple. It is 9C3. Out of 9, you select 3. 9C3 ways. That if calculation, we will get some number. But here not the problem. The question is, in this drawing of 3 balls, must be at least 1 black. 3 black are there, at least 1 black. Means here is the at least. Whenever you see the concept of at least, that means it is not possible to calculate. At least means 1 black ball. That means you see, in order to draw 3 balls means 2 white, 1 black, or 1 white, 1 black, or 1 red. Also 3 balls. Or 1 white, 2 black. Okay, Nana? No, 0 red. Okay, like that also. Because at least 1 black, 2 black also. Or 0 white, 2 black, 1 red. Okay, na? Or otherwise, we may draw 3 black also. 0 white, 3 black, 0 red. Is it possible to solve all these 5 different types of concepts? It is meaningless. So at that time, we will apply one method. At least, whenever the at least concept is there, you simply follow, okay, Nana? Total. You see, number of ways. Number of ways is equal to total minus total number of ways means 9C3. Total without any condition. Out of 9 different balls, 3 balls are drawn means 9C3. So that is a total minus at least getting 1 black ball. At least 1 ball means 2 balls. 3 balls maybe. But not 0 balls. Without black ball is not the concept. At least 1 ball. So out of total complementary method I am using. Total minus. The previous problem, in order to get the number of odd divisors means total minus even in such way. This is total minus, okay, na? No black ball. Okay, na? No black ball. Means 0 black ball. It is 9C3 na? Without black ball means 3 black balls are there. So 2 white, 4 black. So 6 out of 6C3. Out of 6 balls, that means excluding 3 black balls, 6C3 we would subtract. That is 9C3 means it is 9 factorials by 9 minus 3 means 6 factors into 3 factors. Minus 6 factors by 3, 6 minus 3 is 3 factors into 3 factors. Okay, now that is you calculate it. By calculation we can. It is 9 into 8 into 7 into 6 factors, 6 factors cancels by 6 only. It is 6 into 5 into 4 factors into 3 factors cancels by only 1 3 is there. You can easily solve it. It is 3 2s, 3 3s, 2 4s. Okay, na? 12 7s, 84 minus 5 4s, 20. So 64 is the answer. Okay, na? Like that we have to solve the problem. Okay, na? Yeah. Next problem. Some problems I want to solve. There and there. You see, 49 problem is a different one. 48 also a different one. 48. A 5-digit number divisible by 3 is to be formed by using the numbers, by using the digits 0, 1, 2, 3, 4. A very good concept. Please observe it. 0, 1, 2, 3, 4, 5. There are 6 digits are there. By using these 6 digits, we have to frame a 5-digit number. 5-digit number. Okay, na? But it should be divided by 3 without repetition. Without repeating. Total number of ways is asked. It's a very fantastic concept. Please observe it. Observe it. You say 3 numbers are selected from this. 3 digits are selected from this 6 digits. 6p3. Okay, now out of 6, 5 is in it. 6p5. But here you see that number must be divided by 3. Okay, now divided by 3 means the sum of that digits of that number, any number. For example, 369 is there. This is the number divisible by 3. Easily we can 3 into 1 into 2 into 3. Yes, correct. It is divisible by 369 is divisible by 3. Yes, correct. But how can you say, suppose a very big number is there, 123, like this is there. Can you find? Like this is there. 3912 is there. Can you say it is divisible by 3? Not possible. 2 is there in the units place. It is even number, so we can divide with 2. At last 12 is there. 12 is divided by 4. So this is divided by 4 also. We can. But can you say this is divisible by 3? A method is there. It is 3 plus 9 plus 1 plus 2. That is 12, 15. This 15 is divisible by 3. So entire this number is divisible by 3. Not only this number can be by using these digits. 3, 1, 9, 2, 3, 9, 2, 1, 9, 3, 1, 2, 9, 3, 2, 1, like this. That combinations. You use any this number because the sum of those digits is only 15 divisible by 3. So these numbers are divisible by 3. That is the method. Like that, here also we have to choose the digits which are whose sum is divisible by 3. You see, a method is there. You see, 0 plus 1 plus 2 plus 3. Only one digit is needed. 0 plus 1 plus 2 plus 3. If you take 4, this is 6 plus 4, 10. No. If you take 5, no. Okay, na? Same. 0 plus 1 plus 2 plus 3. Okay, na? So we have to, this 4 numbers is wrong. 0 plus 1 plus 2 plus instead of 3, we can write 4 plus 5. 9 plus 3, 12. Okay, na? So it is divisible by. So we may select 0, 1, 2, 4, 5. This is yes, correct. Out of these numbers, we have to take these numbers. That means The number 12,450 by using this one. 12,540 or 15,240, 15,420, like that it is going on. Each number can be divisible by 3 only, because this is 0 plus 1 plus 2 plus 4 plus 5 is 12, that is divisible by 3. Okay, now that is one set. And we will see another set. Is there any another set? Instead of 0 plus 1 plus I delete the 3. If 2 is deleted, you see, it is not possible. It is 4 plus 4, 8, 13 will come. No. If you relate 3 and add 4, 5, it is okay. So, it is not correct. Suppose if you delete 1 and you include 2, 2 plus 3, 5 plus 5, 10, 10, 14, also not correct. So, that is not there. So, then the very next is 1 plus 2 plus 3 plus 4 plus 5 is correct. It is 9 plus 6, 15, divisible by 3. Okay, Nana? It is divisible by 3. So, it is also 12,345, 30,245, 15,000 to something, 240, like that, 243, like that. Okay, now? You see, so here two types of sets of numbers are there. With those digits, the number of those 5-digit numbers can be divided by 3. That is the meaning. First, I want to take 0, 1, 2, 4 and 5. Okay, that number. Okay, now you see this number, not like that. I will write here 0, 1, 2, 4, 5. Okay, Nana? Right. Here, you see, any number will not start with a 0. So, this box, the first box, that is 10,000 place, will be filled by only 4 ways. Because other than 0, 1, 2, 4, 5 is 4 ways. The remaining 3 boxes, by the remaining any, after filling the first box, remaining 4 digits are there, 4 boxes. It is 4P4. That is 4 into 4 fans. That is 4 into 24. 96. Okay, now that is it. And another way, or not and or otherwise, we may select 1, 2, 3, 4, 5. Here is 5 boxes are there, 5 digits are there. Very simple. 5P5, 5 patterns is 120. So total is the total number of 5-digit numerals. 5-digit numerals. Okay, Nana? Is equal to 96 plus 120. 116. 260. Okay, Nana? This is the required answer. Okay, now like that we have to solve the problems. And you see, 49, fantastic concept. There are 10 lamps in a hall. Lamps, lights. Electric lights are there. In a room, 10 bulbs are there. Each one of them can be switched and independent. There are 10 switches and 10 bulbs are there. Find the number of ways in which hall can be illuminated. Illuminated means can be lighted. Okay, now that means in a room, say for example in our classroom, there are 10 bulbs, you will show. 10 switches are there. For each bulb, if you switch on, you put on the bulb, that can be illuminated, so that the room can be lighted. Okay, now 10 bulbs are there. This is a very big room. This is room now. Room. Okay, now 10 bulbs are there. 10 bulbs are there. Okay, now switches are there. Outside switches are there. Okay, now the Ramesh will come, and Ramesh means attend Ramesh will come and switch on the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Separate individually. If you switch on the first one, if he switch on the first one, one light is illuminated. It can be when it gives some light, so that the room can be lighted. Even though 10 lights, 10 bulbs are switched on, the total room is very bright. Even though with one bulb also, it is some lesser light is there. Okay, now? But the question is, we have the light in that room. That is the question. So, out of 10, if you select one, Ramesh can select any one. Out of any 10 bulbs, 10 switches, one is switched on. R means plus. Out of 10, any 2. If 2 is switched, then also the light is increased in the room. If 3, 4, like that. If 10 bulbs are illuminated, so the room is very bright. Whatever it may be, in the room, the light must be there. So this is the method. Okay, now? It is the answer. Actually, this is the number of ways. Okay, Nana? But if you add 10C0, 10C1, 10C1 to 10C2, 10C10 is there, but I am including 10C0. It is 10C10 minus 10C0. I am including 10C0 and excluding. So this is a formula. A formula is there. It is 2 power 10. 10 number. 10C0, 10C1, 10C2, 10C3, up to 10C. A formula is there. It is 2 power 10. A formula is there. Minus 10C0. Any C0, any number, C0 is always 1. So this is the answer. Okay, now? The answer is like that one. Okay, now? A very good answer. How is this formula? I will tell it. I will tell in this here. Okay, now? It's a fantastic. The binomial theorem that is included in our, not included, it is excluded. But in the lower classes, this formula is there, binomial theorem. 1 plus x whole power n means it is nc0 plus nc1 x power 1. It is nc2 x square, nc3 x cube, like that ncn x power n. It is going on increasing. Okay, now? Here put x is equal to 1. It is 1 plus 1 power n. It is nc0. 1 power 1 is 1. 1 into something is something. nc1. It is nc2 into 1 square 1 nc2. It is nc3 dash dash ncn. Okay, Nana? It is 1 plus 1 is 2. 2 power n. It is nothing but 2 power n. So this is the formula I am applying here. Okay, now? Like that. Is it correct? It's clear? Yeah. Okay, please. Thank you, Nana.